to class. I am so glad that you have joined me today. Thank you so much. I want to start today with a little activity. So we're starting Unit 3 now in our live classes. I know that you've been working in Unit 3 in the course for, I guess, since last Friday, so almost a week. Unit 3 actually is going to contain about 40% of what will be on your STAR test. It all comes from Unit 3. So it's a really big unit. We've actually tried to break it up into 2 different units so that it's not super overwhelming for you. So, I need sleep and ice cream too. Seriously, I need sleep more than ice cream for sure. So we're going to start with Unit 3. I'm going to kind of move slow, but if what I'm doing in class today is like too slow, y'all just tell me like, okay, hey, we get this. You can go a little faster. Okay. So, I want you to tell me in the room chat, what do you know? I'm actually going to give some whiteboard tools as well. If you want to label anything from this vocabulary box, you can either tell me what is an ordered pair, you can list an ordered pair, you can tell me what's the origin, you can put a point on the origin, you can circle the y-axis, label it for me, x-intercept, y-intercept. So I'm going to give you about 30 seconds. If you would like to collaborate with me, I would really appreciate that. Thank you, Rylan. Thank you, Amari. I appreciate it. All right, good deal. Y'all are doing awesome. I really appreciate your cooperation. I'm going to go ahead and close out the whiteboard. So let's go ahead and talk about some of these things that y'all have labeled in here. So the first thing we have is an ordered pair. And good, I see that Marley labeled for us, gave an example of an ordered pair. So 1, 2, exactly. So an ordered pair is going to always be written as x comma y, okay? And the numbers that go in here are our coordinates. So what this does is this allows us to describe specific points. So instead of saying like, oh, that point on the right, no, not that one, go up a little, no, now down a little, we can say, that's okay, Amari. We can say 5, 2, and we would go to the right 5 and up 2. Okay, so ordered pairs and coordinates tell us exactly where the point is and what the x value and the y value is at that specific point. The origin is right here. I see someone labeled that. Awesome. Good job. The origin has the ordered pair or the coordinates 0, 0. Okay, so that's going to be where the x and the y-intercept cross. All right, the x-axis runs left to right. I see someone circled it for us. Thank you. X-axis. And then up here, we have the y-axis, and that runs up and down. And then lastly, we have the x-intercept. So the x-intercept is where our graph, this blue line, is considered the graph of our function. It's where that function crosses the x-axis. So I'm going to write that out for you. X-intercept is where the function crosses the x-axis. And let me make that a little bit bigger so you can actually read it. There we go. The x-intercept, when we write it out, is, think about it. If we're going to cross on the x-axis, it's always going to have some number for x, and then y is going to be 0. Okay, the number for x could also be 0, but for the x-intercept, y is going to always equal 0. So likewise, for our y-intercept, which I will put right here at -2, that y-intercept is always going to have a 0 value for x and then a number for y. And the y-intercept is where the function crosses the y-axis. Okay, so some of this might be brand new. Some of this or most of this might be review. Awesome. So any questions, or do you need me to re-explain any of these before we move on? Okay. So today we are going to be working on finding the slope of a linear equation when we're either given a graph or 2 points. Then we're going to write out the equation of a linear equation from a graph. So if we're given a graph, we're going to be able to write out that equation. Or if we're given the slope and y-intercept, we're going to be able to take that and write it out as a function or an equation. Okay, so what is a linear function? A linear function is a function with a constant rate of change. This is also known as slope. Okay, so it is increasing or decreasing at the same rate. Another key feature of a linear function is that it's a straight line. And I want you to notice this word line is actually in the word linear. So linear means it's a line. Okay, and then linear function is an equation that has no exponents. So, for example, this first one, we'll call it number 1. Number 1 is a linear function. It is a straight line. Okay. Number 2 obviously has a curve. It is not a linear function. Number 3 is also curving, not a linear function. So to determine if something is or is not a linear function, we are going to just determine whether or not it's a straight line. Another thing that we need to talk about is intercepts. So I don't know how many of you are like football fans, but think about an interception, right? Like you cross in front, get the ball when you're not the team that had the ball. Okay, so it's a cross. So an intercept is a point where a function crosses, intercepts, no problem, Nate, intersects, okay, the x or y axis. So there's 2 types of intercepts. There's an x-intercept, and obviously that's where it crosses the x-axis. And then if it crosses the y-axis, that's our y-intercept. So let's take a look at some different situations we can have regarding intercepts. This is a graph. We ask ourselves, okay, how many y-intercepts does the graph have? Well, here is our y-intercept. It's at the point 0, -2. So it has 1 intercept, 1 y-intercept. How many x-intercepts? 1. Okay, if it is a straight line, it cannot have more than 1 y-intercept and more than 1 x-intercept. Okay, so it can have 2 intercepts, 1 x and 1 y, but it can't have more than 1 of each. It can, however, have just 1. So this is a horizontal line. I'm going to write that word down here. Maybe. Horizontal. Okay. How many y-intercepts? Well, our y-axis is here, so I go down. Oh, there's where it crosses. It has one y-intercept. This is our x-axis, and as you notice, it runs parallel, so it never crosses. So this one actually does not have an x-intercept. Just like we can have one y-intercept and no x-intercepts, we can also have one x-intercept and 0 y-intercepts. So this is called a vertical line. It goes straight up and down. So does it intersect the y-axis? Here's the y-axis. I come straight down. I move. Nope, don't see it intersect. Okay, so 0 intercepts, 0 y-intercepts. And then over here, here is my one x-intercept. Any questions about intercepts, determining intercepts from a graph? All right. So let's talk about what you went over in the course on Friday, which is the slope of a line. All right, so the slope of a line, we kind of talked about this a little bit already, but the slope of a line is the rate of change, okay? Or when we're given a graph, it's the rise over run, okay? Meaning rise, how much does it go up or down? And then run, how much does it go left or right? Sometimes in a word problem, it will say, what is the rate of change? That is the same thing as slope. So rate of change is another way to say slope. It's the change in y values divided by the change in x values. What does slope do? Slope is what measures the steepness of a line. So how fast or slow we are increasing or decreasing. All right, so what is the formula for slope? Great question. Let's say you are given 2 points, okay? And we talked about in our warm-up that our ordered pairs are x comma y. When we're given 2 sets of ordered pairs, we have to differentiate. So we say this is the first x in the first pair. This is the y in the first pair. That's where these little numbers down here, x1 and y1, that's where that comes from. It's saying this is the x from the first pair and the y from the first pair. This is the x from the second pair and the y from the second pair. Because we don't want to get our x's and y's confused. So the slope formula tells us we're going to take the y value from the second pair, subtract the y value from the first pair. We are then going to divide and take the second x value and subtract the x value from the first pair. When we start putting some numbers in, it will make a lot more sense and won't look like gibberish. Okay, so let's talk about if we just are given a graph, there are 4 types of slope. We can have a positive slope, a negative slope, a 0 slope, or an undefined slope. So what is the difference in these 4? We are going to always start at the far left of our graph. Okay, so that would be over here for number 1. And I follow my graph. If I am going up and to the right, that is a positive slope. So up and right is positive. Another thing you can do is put a little stick figure here. With this stick figure, if they're walking to the right, they are going up. So it is a positive slope. Another thing for negative, same thing, we can use our stick figure. We always start on the far left-hand side, and they would be going down. Okay, so if it's going down and to the right, that's a negative slope. All right, now we have a 0 slope. So if this is you And if you are like me and you live in Galveston, we have like no hills. So if I go walking on my road or the seawall or the beach, it is just a straight path. I don't go up any hills. I don't go down any hills. So what is my steepness, or what is my rate of change? Am I changing my elevation? I'm not. It's a zero change. So this is called a zero slope. It's where you're going to have the number 0 on top and some number on the bottom. People easily get zero slope and undefined slopes mixed up, because an undefined slope is where you're going to have a number on the top and a 0 on the bottom. We can't divide by 0. Okay, so think about this. If this was like the top of a skyscraper and they said, okay, here you are up here. Go ahead and take a step off and tell me how fast or slow you're decreasing. Well, you're not decreasing at a constant rate, right? Like you step off and then bam, you fall. So this slope is not defined. Okay, it's not a rate. It's just straight down. There isn't a slope here. Okay, it is undefined. That is different than a zero slope. Okay, so I want to make sure that I made that clear. That's different than a zero slope. I'm going to also post a link real quick in the room chat. If you want to click on it, this is called Mr. Slope Guy. If this is like in any way helpful to you, great. You can feel free to use him. Basically it's very interesting. So he has one eye that looks like this. So if your line is going up and to the right, obviously that's a positive slope. If it's going down, that's a negative slope. For his nose, it's a vertical line, and they put this U, which means undefined. And then straight across is 0. So you can see that they're using like this U to do undefined, and then like these zeros for 0, the minus sign for negative. Okay, so if that little weird man helps you, then awesome. By all means, feel free to use him. We are now going to talk about finding slope using points. Okay, good. Yeah, somebody yesterday in class mentioned the slope guy, and I was like, oh yeah, I kind of forgot about him. But if that's helpful to you, then you are more than welcome to use that reference. All right, so what are the steps? If we're given 2 points, the first thing we're going to do is label our x1 and y1, x2 and y2. Okay, please, please, please don't skip this step. I know it's so tempting to just think that you don't need it, that you can do it in your head, but I was looking at the quiz and even some of the homework from 3.02 where you had to find the slope, and a lot of people were switching them up. Okay, so just be very careful. If you label, it's so much easier to make sure that you don't make a mistake. Then you're going to plug it into your formula. My best advice, after you've labeled x1 and y1, x2 and y2, you're going to go and draw your division sign, and then go ahead and draw your subtraction signs. You're going to see on this first problem that we do, there's sometimes a lot of subtraction signs or minus signs, and we don't want to forget any of them. So by automatically putting that in there, this division, subtraction, that's all part of the formula. So we can just go ahead and set it and then plug in our numbers. Okay. Then we're going to subtract and simplify if possible. Let's see what this looks like with points. So they gave me 2 ordered pairs. So the first thing I'm going to do is say, okay, this is my x1 and y1. This is x2 and y2. All right, so my advice to you, remember, was to go ahead and draw your division sign and your subtraction signs. I'm now going to follow this formula. So y2 is -8. I already have my minus sign. Now I just plug in y1, which is -5. Yes, you have to include that second negative. As you can see, there's a whole lot of negatives, and it would be really easy to just put -8 minus 5, but there has to be 2 because one's part of the formula, 1 is the number that comes from our ordered pair. And the bottom of our formula says to go ahead and plug in x2, which is 0, and then x1, which is negative 12. So if you're confused, if you're not 150,000% sure, plug this top into your calculator. Just type in -8 minus -5. Okay? -8 minus -5. Minus a negative becomes plus. So this is -8 plus 5. That's going to be -3. On the bottom, 0 minus -12. Minus a negative becomes plus. So I'm going to get 0 plus 12, which is 12. Does that make sense, Rylan? Okay, where did I lose you? Which part? Okay, Micah, where did I leave you behind? Which part? Like the top, the bottom, plugging it in. Okay. So, if I just had -8 minus 5, right? So let's say I'm on my number line. Okay, here's -8. If I'm subtracting 5, I'm going to go 5 to the left, right? 1, 2, 3, 4, 5. But if I'm subtracting a -5, that means I'm going the opposite, right? That double negative becomes a positive. So I have to move then to the right. So it's really adding. That's why that's the only reason that this concept is tricky, is because of those double negatives. Okay, so that's why I want you to write out your division sign and the two subtraction signs first, and then go back and plug it in. If that's confusing, I totally understand that. Okay, that's why I wanted you to do that. You can plug that double negative into your calculator. So you can use the little negative sign. So -8 minus -5, and it will tell you that it's -3. You can't use the, let me just share this real quick. Tools. Okay, so when I type this in, this is the negative button down here underneath the 3. -8. Now I use the big minus sign that's above the plus sign because that's part of my formula. Minus, and then -5. Hit enter. Boom, -3. Okay. So if you are at all confused or you're not 100% sure of your math in your head, just use your calculator. Now that we have this -3/12, correct, Micah, exactly. Yep. We need to simplify. So I'm going to divide the top and bottom by 3. Okay, we have to divide the top and bottom by the same thing. So now I'm going to get, as my final answer, the slope is going to be -1/4. Please, please, please keep this as a fraction. Do not change it to a decimal. Okay, the reason is when we go to graph and we use rise over run, if I said, okay, here's your rise over run, 0.25, that does not tell you how many to rise and how many to run. Okay, so please do not change it to a fraction. Please don't change it to a decimal. Just keep it as a fraction, okay? All right, so let's go ahead and try this one. So first things first, label your X1, label your Y1, label X2, label Y2, and then Come down here, draw your division sign, draw your subtraction signs. I'm going to pause for a second so you can do that on your own paper. Okay. Y2 is negative 16. Y1 is 6. X2 is negative 15. X1 is 19. Again, just type this into your calculator. You do not have to do it in your head. Negative 16 minus 6 is going to give us negative 22. Negative 15 minus 19 is going to give us negative 34. Now we simplify. Okay. A negative divided by a negative gives me a positive. Yep, good, Micah, exactly. Negative divided by a negative gives me a positive. So I'm going to have positive 22 over 34, and then I'm going to simplify again. So I'm going to divide the top and bottom by 2. Yeah, same thing with multiplication. Multiplying by 2 negatives is a positive. When I divide the top by 2, I'm going to get 11. When I divide the bottom by 2, I'm going to get 17. Any questions about finding slope using 2 points? Okay, let's talk about, this was one of the problems on your quiz. Not this exact one, but actually, let's do this one. Sorry, give me 1 second. Where are my... Okay, here it is. If you are given the slope and the y-intercept, okay, so slope is represented by the letter M. Y-intercept is represented by the letter B. So on your 3.02 quiz, they would tell you something like, your slope is 1/2, your y-intercept is -3, write the equation of a line. Okay, slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. Okay, so all we have to do is plug it in. Okay, so if they tell you slope is 1/2, I'm going to say, okay, so that's m, y-intercept is -3. Oh, okay, so that's b. I'm just going to plug it in. Slope goes in front of x, b goes down here. So this would be 1/2 x minus 3. All right, so now I'm going to give you a problem. Suppose the slope of a line is 5. The y-intercept is 2. How would you write the equation of this line in slope-intercept form? Well, first of all, what is slope-intercept form? It's y equals mx plus b. So what is my slope? Slope is m. They told me slope was 5. The y-intercept is 2. So I'm going to rewrite my equation of a line, but instead of putting m and b, I'm going to plug in the numbers that I know. Good, Micah. So this is going to be 5x plus 2. let's take it a step further. The first thing we're going to do is write the equation of a line that has a y-intercept of -3 and a slope of -4. Okay, so let's label what they just told us that we had. The y-intercept is b, slope is m. So I'm going to write this out in slope-intercept form. So tell me in the room chat, what would my slope, or what would the equation of my line be? Good, Micah. Good, Amare. Yep. Anybody else? Everybody with me? Anybody with me besides Micah and Amare? Okay, awesome. Thank you, Nola. Okay, so I'm going to, instead of m, I'm going to plug in my slope, so -4x plus -3. You probably won't ever see it written as plus -3, so you'll probably see it as just -3. Okay, now here's another question, taking it a step further, that was on your quiz. Is the point 1, 2 a solution? What does it mean for it to be a solution? That means it's on the line, okay? So if it says, is this a solution or is this on the line? What we are going to do, this is just an ordered pair. So this is x and y, okay? So I'm going to type this up here. To determine if a point is on the line or a solution, plug in the ordered pair and check for a true statement. So I know that seems a little bit vague at the moment. Let me show you what that looks like. Okie dokie. This is our original equation. So instead of putting a y, I'm going to put in the number 2. So 2 equals -4 times 1 minus 3. Correct, Amari. That's exactly right. So 2 equals -4 minus 3. 2 equals -7. Is this a true statement? Is 2 the same thing as -7? It is not, right? 2 does not equal -7. So therefore, is that point on the line? No. If we would have gotten the answer 2 equals 2, then it would have been on the line. Okay? So if it asks you to determine if a point is a solution or if it's on the line, you are going to simply plug in that ordered pair, plug in the x, plug in the y, and see if you get a true statement. Okay, we have 10 minutes left. The last thing I want to cover today is how to write the equation of a line if you are given a graph. Make this big. Okay. So, first things first, step 1, you are going to find B, or your y-intercept. So B equals. My y-intercept is where we cross the y-axis. Very good, Micah. So that would be right down here. 1, 2, 3, 4. So B equals -4. Step 2 is going to be to find the slope. Okay. When we count slope, remember that m was rise over run. Okay. So in my slope, if I go up, okay, that's a positive number. I go down, it's a negative number. If I go to the right, that's positive. If I go to the left, it's negative. What do I mean by that? Okay, so what you're going to do, the reason we find the the y-intercept first is because we start at that point and we are going to count rise, how many we go up or down, and how many we go left or right until we get to another point that crosses at a whole number. So I'm going to use the point, let's do this one just to give us some space and give us some counting practice. So I'm going to start at my y-intercept and I'm going to say, okay, how many do I need to go up to get to that green point? I would go up. Oops. 1, oh my goodness, come on. 1, 2, 3, 4, 5, 6. So up was positive, up 6. And then I'm going to go to the right, 1, 2, 3. I went to the right, so that's also a positive number. 6 divided by 3 is 2. So my slope is 2. Okay, now I know my slope. I know my y-intercept. I'm just going to now plug it in to y equals mx plus b. So the equation of this yellow or orange line is 2x minus 4. All right, I want to do another one. I'm going to have to paste it on here because my grid did not show up. Okay, so here is another one. Step 1, find b. So b equals 1, 2, 3. Good, Micah. Step 2 is to find slope. All right, so again, I start at my y-intercept. I'm going to go to another point that crosses at a whole number. So what do I do from here? All righty, what am I doing? I'm going 1, 2, down 3. Okay, so for my rise, it was actually down 3, which is a negative. Down 3. And then I went to the right 2. Right is positive. So my slope is negative 3/2. We're going to leave it as a fraction. Now, all I have to do is plug that into my slope-intercept form of a line, which is y equals mx plus b. So we would get y equals negative 3/2 x plus 3. And that's it. Okay, so what I would, B is 3, Rylan, good question, because that is the y-intercept. So this is the y-axis. So we're asking ourselves, where on this dotted blue line does my function, my linear equation here, where does it cross? And it crosses at the point right here. And this point would be 0, 3. So our y-intercept is 3. It's asking, what is the y value? Good question. Okay, so if you have not taken your 3.02 quiz, I know there was some problems with it, like counting something wrong, even if you wrote the equation correctly. I don't know why it's doing that. I'm sorry about that. If that's happening, just send me an email. Okay, let me know that happened. If you have already used all 3 attempts on your 3.02 quiz, but Now that we've gone over this together, if you would like an additional attempt, I would be happy to unlock that for you. I just need you to raise your hand right now if you would like an additional attempt. If you still have attempts, I want you to go take your, or you have not taken your quiz, I would like for you to go log into the course now and do that. Does anyone need an additional attempt on 3.02?